Okay, let's have a look here. A circle K has center 1 minus 2, chord AB, where AB is 4 root 3. The point D is the midpoint of the chord. Find the radius. Okay, it's a bit of a Pythagoras, really. I can get this distance pretty easily, and we know this distance here, it's 2 root 3, so I can get the h there. So the r squared would be 2 root 3 squared, so that's 4 times 3, so that's 12, plus this distance squared, so that distance squared, so that's square root the difference in the x's, that's 2 squared, which is 4, plus the difference in the y, which is 4 squared, is 16. So that's 12 plus 20, which is 32. So that means that is 4 root 2 when you square root 32. Okay, so that's the r taken care of. Show that the circle and the circle, these two circles, touch externally. Couple of ways to do it. You could calculate the distance between the centers and show that it's equal to the sum of the radii. So I'm just gonna, I personally like to complete the square here, so I can get the center and the radius. So I can change this into x plus 2 squared plus y minus 1 squared. So if I look at that, that gives me x squared plus 4x plus 4 plus y squared minus 2y plus 1. So there's a plus 5 here, but I need a minus 95, so that's minus 100. So that's equal to 100, so that's equal to 10 squared. So the distance between them would be the square root x1 minus x2 squared and y1 minus y2 squared. So this circle is centered at minus 2, 1, and the other circle is centered at 7, 13. So that's 9 squared and 14 squared. 12 squared. 12 squared, 9 squared. So that's the square root of 144 plus 81, which is the square root of 5. Oh, that's 16. And note that the distance, which equals 16, is equal to I must have done something. Oh no, 225. No, it's 15 squared, not 16 squared. So note that 15 is equal to 10 plus 5, which is the first radius plus the second radius. So therefore, they meet externally, because we've shown the distance between the centers is equal to the sum of the radii. Okay, so that's part 2 taken care of. There are an infinite number of circles which touch circles. Actually, do you know what? I can check the answers here just before continuing. Let's have a look. Let me just check on the website. 4 root 2 is correct, and yeah, that's correct. All right. Now, when I first did this question last year, I did it without the marking scheme. I was doing it on the day the exam came out, so I actually never checked if I got the right answer. So let's do the last part and check if it's right then afterwards. There are an infinite number of circles which touch circle C externally at the same point that S touches C. Find the coordinates of the center of one of these circles apart from S. Okay, so you've got your two circles. C and then S. And you know the location of the center of C and the location of S. And we just want another circle here that touches externally at the same point. So I think the idea I had last year, and I still like the idea, is if you draw a line connecting all three, all you have to do, I think, is just push this point further out. That's all, and that could make a bigger circle. So to push it out, we just need to study how we transition from here to this point. So we start off at -2, 1, and this radius is 10 units, and this radius is 5 units. So you can break it up into 1, 2, 3 equal jumps. So a transition from here to here of 5 units, and then another 5 unit transition, and another 5 unit transition, and we'll just do one more 5 unit translation, I should really say. So -2 to 1, some middle point here. Let's make a bit more space. Okay. So -2 to 1, to this one, to this one, to the last one, which is at 713. So what must I add to -2 twice to get 7? 4.5, isn't it? If I add 4.5 twice, and then what would I add to 1 twice to get 13? I'd add 6. So if I add 6 to that, I get 7. Then I add 6 again, I get... Oh, no, that's not right. That's not right. Sorry, it's not twice, it's 3 times. So what do I add to 1 3 times? I add 4. So I get 5, 9, and then at 13. Okay, and what do I add to -2 3 times? I add 3. So -2 plus 3 is 1, plus 3 again is 4, plus 3 again is 7. So each transition was a +3 plus 4. So if I continue that one more time, I get 10, 17. And that would be like here. So 10, 17. Now, because there's an infinite number of answers, I wonder how the marking scheme is going to present this. Let's have a look. Let's see. So they give an example. Accept any point on the line y equals 4x plus 11 over 3 for which x is greater than 4. Okay, it's not that solution. Looks like they're doing something similar with the transitioning. -2 to 1 to 7, 13. Yeah, so they did it the transition, but they pushed it out further. And that's kind of funny because I think that's what I did last year. I have to look at the video. I think what I did was I transitioned from here to here and then transitioned the same distance out again. I think that's what I did last year as well. So if you did it that way, it would be further out. So -2 to 1 to 7 to 13. So that's adding 9. So that's 26. And then that's adding 12. So 26, 25. Oh, sorry, not 26. Adding 9 to 7 is only 16. 16, 25. Yeah, that's right. And then, I see. The third solution they have is 10, 17. So yeah, that one they accepted. Yeah. And I think when I did this last year, I kind of remembered that I did it this way, which I think, yeah, that's actually quicker and easier than what I just have done right now. But that's also acceptable as well. But because there's an infinite number of solutions, there's many answers obviously you can get here that's right. But there are two answers that are actually listed in the marking scheme I see. Okay, so I think that is the end of that question. Okay.